Alrighty, so I'm solving problem 10 from chapter 4. So the question asks you to find a 1 by 3 matrix and a 3 by 3 matrix whose null space consists only of vectors x1, x2, and x3 of R3 that satisfy the equation x1 plus 2x2 plus 4x3 equals 0. And so we can show first for a 1 by 3 matrix that the matrix 1, 2, 4 works. And we can say that it already works because it's already in reduced row echelon form. So we know that 1 is going to be the pivot, and we know, so then we can rewrite this reduced row echelon form as x1 is equal to negative 2x2 minus 4x3. Or similarly, you can express it as x1, x2, x3 is equal to x2, negative 2, 1, 0, and then plus x3, negative 4, 0, 1. And so we can see that if we're finding the null space, we want to find the null space, right? So the null space of A is going to be the span negative 2, 1, 0. Sorry, I'll try to pick up my pace a little bit. Negative 4, 0, 1. And we can test that in the original equation to make sure that it satisfies this. We can see that negative 2 plus 2 times 1 plus 4 times 0, that checks out to be 0. And then we can also see that negative 4 plus 2 times 0 plus 4 times 1 is going to equal 0. So that checks out. And so for a 3 by 3 matrix, similar to this example right here, we can say that the 3 by 3 matrix that works, or that is in R3 that satisfies, sorry, my apologies. The 3 by 3 matrix is not going to be in R3. The vectors within the null space are going to be in R3. And so we can say for the 3 by 3 matrix that we can really just say it as 1, 2, 4, 0, 0, 0, 0, 0, 0. And this is because this matrix here is in reduced row echelon form with a pivot here. And we can form the same equations as before. So same as before, it's already in reduced row echelon form. And then from this equation, from this matrix here, we can express that x1 is equal to negative 2x2 minus 4x3. And then just 0 is equal to 0, and 0 is equal to 0. And so from this, we can say the same thing as before, where x1, x2, x3 are just like that. x2 is negative 2, 1, 0. And the math just continues as is. Negative 4, 0, 1. Boom. And then we can say that, so for both of these matrices, the null space of the matrices consist only of vectors that satisfy this equation, because as similarly up here, we can just prove plugging the two vectors from the null space of the matrices into the original equation that it must satisfy. We can say just like this, equals 0, and negative 4 plus 0 plus 4 is equal to 0. And so we see that a 1 by 3 matrix and a 3 by 3 matrix whose null space consists of all vectors x1, x2, x3 of R3 that satisfy this equation. The two matrices 1 by 3 it's going to be 1, 2, 4. And the 3 by 3 is going to just be 1, 2, 2, 4, 0, 0, 0, 0, 0, 0.